Hello and welcome back to test number 3, looking at math skills and how to answer biology questions. So this one has got 5 questions in and we're going to have a look at some different skills you need to learn. So in question number 1, a scientist counted the number of bacterial colonies in 7 petri dishes. Her results are shown in the table below. Give the median number of bacterial colonies. So this time we want to know what is the middle number. So all I need to do first of all is take these 7 recordings and put them into order of size from smallest up to biggest, and then work from each side and work out which one is right in the middle. And the answer, if I go 3 in this way, 3 in this way, and the answer is 43. Straightforward 1 mark question. Okay, this question then, the inverse square law links light intensity and distance. It can be represented by the following formula. Okay, so light intensity 1 divided by distance squared. Which statement A to D explains what the formula means? Light intensity is proportional to 1 over distance squared, and that's all that means. Okay, so that's an easy one. Okay, question 3. A group of respiring woodlice produce 4.37 centimetre cubed of carbon dioxide in 1 hour. Calculate their mean rate of carbon dioxide production per minute and give your answer to 2 significant figures. Don't forget to do this or you will lose the second mark. So I'll take 4.37 and all I need to do is just divide it by 60 because that is 1 hour. I want it in minutes and there's 60 minutes in an hour. And the answer is 0.0728. However, my answer has got to be to 2 significant figures. So if I look, I've got 0.7 and then that is going to be 3 because that 8 is higher than 5. So 0.073. Okay, question 4. Peter recorded his pulse rate during 4 different activities. His results are shown in the table below. Draw a bar chart of Peter's results on the axis below. Now I always try to draw bars to make sure they are equal width and that there is a space between them. If there's not, then generally that's a histogram. So first of all, I needed to plot the axes. Now because this was a bar chart, because I know my writing's a bit bigger than normal, so I wrote my labels this way, so I knew that I could get them in. If you notice, I also drew my bars to the right hand side of each of the boxes, so I made sure they were all equal widths. And then on the scale here, I knew I had to get up to 136 was the highest part of the range. So if I'd have done it in 20s, 20, 40, 60, 80, 100, I wouldn't have got far enough. So I tried 40s, 40, 80, 120, 160, that works. And then when I actually plot my points, so the first one is 68, I literally use a pen and I go, right, okay, there's 60 and I count up to 8. And I actually do 2 dots first of all, and then I use my ruler to make sure I join them all up. And then there can be no arguments then about my bars, and I know that I've got all 3 marks in. Okay, and then this question, question 5, a student randomly placed 5 1-metre quadrats in a 60 by 70 metre woodland. He counted the number of bluebells in each quadrat. The table below shows his results. Use the mean number of bluebells per metre squared to estimate the number of bluebells in the woodland. Okay, so I've got a big area here of 60 times 70. So if I work out the area of the woodland, 60 times 70 is 4,200 metres squared. That means I've got that many squares. I need to work out the average for 1 square. Now the thing that does throw some people sometimes is the fact that there is a 0 there. You still count that in. So you add up these first, 2, add 12, add 7, add 0, add 9, equals, then divide by 5, and that will give you your mean average per square. And in this case, it's 6. So the mean average per square of bluebells is 6. But I've got 4,200 squares, so that times that equals 25,200. Okay, thank you for taking part.